Okay, in this session, we discuss about the set. Okay, what is a set interface? And then go for the map. First, this set. This set is one of the interface from Java collection. And this having some number of implementation classes, that is hash set, linked hash set, and reset. Now, first understand that what actually is it and how it is different, compared to the list interface, and what is the benefit of set over list interface. Okay, now this set is an interface that is available in java.util package. You could say this one, this is set is one of the interfaces, and they have this main implementation classes hash set, linked hash set. Sorted set is again implementation class, and tree set is one of the of this sorted set. Now, what is this set? Actually, it's a kind of, this is also a collection, most widely used in the programming languages. So when do we use this set? If you don't want to store the duplicate elements, which means that if you want to store that element only once, means one element only once. For example, now in real-time scenario, we have a configuration values, right? The configuration is only once, right? You cannot have duplicate the values, right? Configuration values, if you store duplicate, right, it is again duplicate data. Right? Data should not be duplicated. At any real-time transactions also, IDs will be, right? You should have the unique data. So in such scenarios, we go for the set interface. If you want to store the elements, right, only one copy of that. You don't want to store the duplicate copies. And if you want to store the duplicate data, and this is unlike array list, this is unordered collection of or unordered list in which duplicates are not allowed. Which means array list, how it's stored, the way you add, it will display like that. It will not be sorted by default. And this guy set is unordered. It does not maintain any order. List maintain order. However you add to the list, right, the same order it will be retrieved for you. Custom sorting you can do on top of that one. But this set, no matter how you add this order will not be guaranteed. This guy always give the elements in unordered format. And said it can have at most one null value, which means that it cannot add more than one null value. How it will learn, why it will learn, we will see during hands-on. And here, difference of this is an array list. It works on the concept of array. So that is the reason we have option to retrieve by index base. However, here set is not working or not supporting the indices of the element. That's why we don't have the method to add element by index to retrieve the element by index. And set support generics also. Now, this all the implementation classes that set currently support hash set, linked hash set, and tree set. Now we will discuss in detail about the hash set and tree set. And linked set is same as our linked list, and the only thing is it implement the set interfaces. Now before go back to this, right, to see that this set having the methods, but compared to this implementation classes, again it has limited methods. Each implementation class has different set of methods out there. Whenever you implement a set interface, then you will acquire only those methods available in the set interface. Now you see this first method of class, you just take a new class of set. Okay, yeah, set program. Now we see that, as we told, right, set will not allow duplicate elements. First we said take that unique numbers. Now I have here 3, 9, 1, 4, 7, 2, 5. Again 3 is repeated here. Say this element 3 is already there. Again if you see 9 is there, here also there, and 1 is there. Again 3 is thrice it is, right? 8 is twice, 3 is repeated thrice, and 1 is repeated twice. How do you say this? Before I say this in the list, this guy is allowing duplicates, right? This list. When I print this list, you could see all the numbers that you have added as a part of duplicates. The moment you pass this list to set, this guy automatically filter out all the duplicates and give you the unique numbers. Now you see this one, how it prints. Okay, let's make a static method. No need to create object. Public static void, and now I call this method with the help of class. What is that? Java set program dot unique numbers. Okay. Now just run the program and just concentrate on only on this piece. Run as Java application. Now you see this 3 comes only once, and 9 comes only once, 8 comes only once, right? It remove all the duplicate elements. Which means this is how you can prove set will not allow duplicates. So there this hash set, right? Yet internally implement a hash map. What is this hash map? This it maintain a index based that, which means every element it's store based on the reference that, which means that map is a key value pair, right? So key is associated with some address where you want to place the element. First the key decide that. Before you place the key, address, or soon after you place the key, address will be retrieved for that key and the value will be placed. That is the reason, right? Address that will be unique means that it generate a hash code. Hash code will be generated, and based on the hash code, then it checks that element is already there. If it is already there, then it will not try to store that. If you say 3 is added first, again, if we search for the next index, this guy is already available, so it just slide silently override 3 with this 3 only. However, if you write any number of times, then you could say only once. So this is how we can prove set will allow, sorry, set will not allow duplicates. List is allow duplicates. You could see this one. When you print this one, you clearly see all the elements that are added to this array list are displayed as is. Now, coming to this another one. Here, iteration of list, we have a number of ways, right? Like for each, for loop, and another Java 8 features also, iteration also there. Like said, we don't have this indices based. And how you do that? Using iterator, we can iterate that. So what do they? This iterator is same as list iterator. How we use this iterator to iterate the list? The same way, and for each also. Again, you can use our normal for loop also. Well, see this one. What methods are available for this? Set add all. You can clear contains all, right? Hash code is empty, iterate, not fair, remove everything. Most of this, right? Few of the methods are like array. Array also you can say add element and remove element is there. But however, if you go to the array, right, remove element based on index. Here you don't have any index base. Now you see this, there is a clear method whichever seen this. Okay, now here it is printing that cities all that are added. Now say after clear, what I'm going to see now, it in one step it clears the entire object. Then say clear. The moment I say clear, sorry, this should pull out and put it here. Again, after clearing, you print this. Okay, now you see the difference. See, before clear you have 4 values, and after clear, right, empty set. So this clear will say that it clear the entire object. Now, up to this, here is fine. That we know that, right? How to iterate that. And contents is method nothing but it checks that given element is there in our set or not. If it is there, match found, that will display. It means it is a condition. Just no matter what code it is there, I just say that match found, which means contains return the boolean value. Returns to if this set contains the element, the specified element. Okay, if this element is there, then it returns to, otherwise it returns false. It will not go inside. Now you can also check this. Compare two sets. How do that? If you have two sets, right? Set 1 and set 2, and set 1 contains all the elements of set 2. Yes or no? Then it says if yes, then it matches, which means this set 1 contains, you have to think about the left hand side, because we are comparing S2 with the S1. Means does S1 contains all the elements of S2. S1 contains 89 and 8, and this guy contains 8 and 89. If yes, means 2, this S2 contains 2 elements, and these 2 elements are already there, which means this contains this data. So that way you can check. When what is it? This S2 is a subset of S1, which means subset means it is a part of S1. When subset means it is some part of S1. Like way you can check this contains all method. Now, some case that if you have two different set objects are there, and if you want to merge those two, like array list, right? We have a or add all method. Same way here also it is add all method are there. We have two different sets, right? So 1, 3, 5, 7, 9, 9, 2, 4, 6, 8. See, these elements and these different elements are totally different. That you could see, if you say x add all y, means for x, then you add y elements. Then you could see this after union, you could see the x will be into the x, you are adding the all the elements of y. Then you see this one, what happens this here. Okay, I'm adding this, right? Okay, is subset is done, and yes, before union, you see this before union, and after union, you could see 1, 2, 3, 4, 5, 6, 7, 8, 9. You could see this one, all the elements of y is getting added to this x and gets displayed here. Now, can see there is one more method also, right? Intersection. What is this intersection? Intersection means just you want to get the common elements from two sets. How you do that? There is no method direct intersection. It is a retain all. Retain all means that are it checks that the matching element from both the sets, which means that A contains the matching elements of from the set B. In the A, right, you see this 2 is there, in the set B 2, in the set A 4 is there, and no matter here it is 6 is there or 8 is there. Okay, then just intersection of these two elements, right? What elements are there? It takes the intersection of from there 2, 4, 6. Right. So before intersection, if you see this one, all this guy gets displayed. After intersection, what you will say? Okay, it will give only the common elements. Now see this, what happens? Now after intersection, you see only 2 and 4, because 2 exists here and 4 exists here and here. It is something like our intersection join of SQLs. Intersection in the sense, right? It checks this AM element is there in both the places. If that exists, means that is there in both the places, and place 1 and place 2. Then intersection of this element is nothing but the common element which exists in across two places. Then that is called intersection. The same way we are doing that in the set also. In set A contains B, then it will add only those elements and produce the output of that set. So this way we can intersect also. And here also one more thing is difference. Difference is nothing but we say remove all. There is no direct method like difference, but this may confuse, right? Retain all, remove all. What you do remove all, right? Removes from this set all of its elements that are contained in the specific collection. So what it is trying to do, it try to remove that elements which are matching. Here what it is doing, it is checking the intersection. This difference remove all is the opposite of this guy. What it is doing, it is taking the intersection of element. What this guy do here, remove all means the matching element will be removed here. So here 2 is here, 2 will be removed from the second set, and 4 is there, 4 will be removed, and next is no, that's all. So 2 4 will be removed, then you could see output 1 3 5 7 9. You could see this 1 1 3 5 7 9. Now this is all the main methods, and you have some more methods that you just go play around with that methods. Now you say this set is not synchronized, right? Then how do you make this set is synchronized? We have a collection start synchronized set. The moment to say this, right? Synchronized set. Then this will be create object synchronized set, and say this set object will be set, which is a static class which make your object as synchronized. So this way we can synchronize explicitly. List also the same way we can do this, right? List also collection dot, right? We can have synchronize collection dot synchronize list. Now list is not synchronized, we discussed, right? List is not a synchronized. By default vector is synchronized. If you want to make the list also synchronized, you can have new option to use this collection dot synchronize, which is a static method that will help you to make your list as synchronized. See that how this synchronize, say this is a utility class that we have discussed, right, during the first session. The collections is a utility class which contains all the static method to act on your collections. So this way we can make synchronize. So one log code, right? You can explicitly synchronize. Once you synchronize this method, these numbers will be synchronized. You can go ahead with the process. Okay, up to here, this is fine. What happens this now? Tree set is there. One another implementation is tree set. What this tree set is there? Why do we need tree set if you already have a hash set is there? And why you need again a tree set? This hash set is not guaranteed of your order. Even this tree set also, it does not contain any duplicates. But this tree set gives you order of its element based on their values, either by natural ordering, or you can use your comparator, like comparator comparable interfaces are there. So you can go by that, which means it give you the guarantee that elements that you are ordered are ordered. This also similar to set. The only thing is it print all your elements in the order. Now to see this one, it takes separate class as tree set program. Okay, now set is there, hash set. Now so this has to tree set. Okay, before we go to tree set, let's see the now printing. Okay, how this elements gets printed here. See here, mouse donkey. See, there is no ordering here, right? No order here. First element, you say forget about this. Sorted. See, mouse M D H E C C is coming in between, right? F is here and G is here, no order. Now what to do? I just pass this object to the tree set. Then tree set automatically convert this list to sorted way. This, see now how it is printing in that sorted. See now it is converted. C D D E F G H I J K L M N O P Q S W. So this tree set will help you to convert this list or set to sorted set. Iterating of this set is same as our hash set only. There is no much difference. So that the same way you can iterate this one. Okay, we just copy this, or you can say iterate that. You can write here. Okay, the iterator and say what type of values it is saying equals to what we are trying to iterate. Animals we are iterating. Animals dot iterate. You see this, somebody asked a question, what is iterator and iterator? Iterator is an interface that has maintained that, right? And it contains a method to iterate the collection. What about the iterator? Again, iterator is one of the method in the set interface. So those are two different that. So why iterator is coming from the set and iterator is different with the interface. Then iterator is interface. It contains method how to iterate and what to while iterating what to do and how to process your collection element. And iterator is the one of the method in the current collection set, and that is a hash set, right? A set or tree. Then using this iterator, then you process all the elements. Using this iterator interface, you iterate that collection object. You see now, while it dot has next means the next element is there in the list. Then say it dot the next element printed. Yeah, this all but this has said. One more thing I would want to talk about here, generics. In Java, we have a generics. Other, what is generics? What is that? Generics are used to avoid typecasting issues. Which means while creating a collection, we have to specify that what type of values your collection wants to hold that. We said during compile time only, it will help you, right, not to store such values, right, inconsistent data type values. For example, in our case, the set is created to store only string values, and you don't want to store any other data type values. Okay, that's it. Now we will create one new class for this and say generics. Okay, now let's see this. Now let's take set only. Okay, now I just say set here. Right now I don't use any generics. It's a simple okay, what we say numbers equals to new hash set. Okay, here also I don't use anything here, just like that. Now what we say this, right, first you can say add. What I'm adding here, adding. So next numbers that add. I will add a integer also. Now you see there is no error here, but storing the data like this with multiple data types is a problem, right? And if it is this type of values, okay, agree. But in real-time scenario, if it is expected to store the values of type, given type, that is a custom object. Mostly we are storing the custom object data. Okay, let's think about the final classes as string and integer. Now here it is accepting string and integer values and double, no matter how many values you that. Now if you want to prevent that, now for example, now what happens, right? If you convert that string somewhere, this string value to integer, this will easily convert that string to integer. However, when you try to convert this string to integer, what happens? Then you will get the cast exception. How is that? You can see now, try also. Okay, integer I equals to what if say integer dot parse int. Now if I try to parse such thing, what you could see this exception will come. Okay, run this program. You could see number format exception. But however, you pass this something like this. This works fine, right? So to avoid this type of errors, to avoid this cast exception, then you have the generics. So how, where you define that, you can say that. Now we can say integer. See, my collection wants to store only values of type integer. Now you see this during compile time only, you could see that when I try to add into string data, then it will gives you exception. The method add integer in the type is not applicable for the argument string. Means the method add is always expecting a data type of integer. You are trying to add a string values. But if you say string, then you can have both this and this. So this way generic will help us, right, to avoid typecasting exceptions during runtime, because we are not storing this compile, right? Compile time anyway it will store that. During runtime, how you do that? So when you are running your program, you are dynamically filling these values from the backend system, right? Once the backend queries, right, once we query the database, right, the database result will be coming and storing into our collection object. Right, you will face a class cast exception. The object which you are trying to add to this collection is not matching. Then immediately you throw that class cast exception. Then you are safe to proceed with the next step. If that exception happened, then we go and fix that. What type of object? Why that? What we are expecting, and the object is coming in a different format, so we can fix it without any problem. So this is how the generics help us. Now go back to this one, and we discuss this set, tree set, hash set. Oh, when do you use for tree set? When do you use hash set? Again, the interview question. Hash set, again, if you don't care about the order of elements, and but you want to store the distinct elements, right? Unique elements, or which means can only exist once in a set. Then we go for the hash set. And if you want to maintain the order, then we go for the tree set. But again, it is say the performance will be degraded if you use the tree set, because it has to rearrange the elements according to the order, right? Which element has to display first and which element has to display last. Then it is maintaining the order. Say it is rearranging the elements in the or shorter format. So compared to hash set, tree set will be a bit slow. And note that the set interface does not provide any API for retrieving elements by index base, as it is not implemented by the array concept, whereas array list is implemented using array concept. This set is used using hash map, hashing technique. So that is the reason we don't have any specific element retrieval of specific elements. And except tree implementation allows retrieve the first and last element. That method is there, like vector, how we have the method to retrieve the first element and last element. Tree set, we have the additional method to retrieve the first and last elements. And this set itself is not synchronized. All this link, hash set and trace set, all these methods, all these classes are not synchronized. And if we want to synchronize them, we know that there is a method called collection dot synchronize set, synchronize list, synchronize map, right? Anywhere, yeah, all the number of methods are there, right? If you see collections, see collections dot, you could see this. The meant to say synchronize, what you can pass synchronize is synchronize map, synchronize set. Which means here, if they have provided this methods explicitly, synchronize set in the sense, then by default set is not synchronized, map is not synchronized, and list also not synchronized. You could see here you have not seen vector, synchronized vector. Why? Vector itself by default is synchronized. That is the reason. Any class that is already synchronized will not have this method again to synchronize that class. Here list interface is not synchronous, map also synchronous, not synchronous, set interface also not synchronous, but whereas vector is synchronized. That is the reason they have not provided to synchronize that vector. If you want to synchronize this all non-synchronized list, that you can go with collection dot synchronize list method according to the collection you are using. So this is how you can synchronize your collections done. And in Java 1.8, we already have a synchronized hash map. See this one? See, synchronize. Okay. Let's create a map. Then you could see this map. Okay. Oh, sorry, we still not covered hash map concept, right? That we will see during our discussion of hash map. That if I say, then we'll confuse that. Next topic is the hash map only. We will cover there about what is synchronous hash map as a part of this. Okay. Concurrent hash map also there. See, when saying we say this concurrent hash map is there in from java.util concurrent hash map. We will discuss all about this concurrent map and concurrent hash map, right? In the next session, what it is does. Once you understand that what is the hash map also not synchronized. To synchronize that, we have a synchronized map. That now we say in the next class, I will show that instead of creating a map and synchronize them, we already have a concurrent hash map, right? That will help us to understand in detail. Okay, right now we will end up these things, and tomorrow we discuss this map and the implementation classes and the way of synchronizing that. So we'll end up this Java, core Java here. Any doubts on this